functions. Section 7.2, just going to kind of go over 2 or 3 examples here, try to make this as quick and painless as possible. We have a few terms that we need to include, and then just, get through it. So, the first example here, just simply take a table of values. When we're dealing with polynomial functions, especially greater than the degree of x squared, degree of 2, you'd want to try to include as many values as possible, and sometimes you might even have to graph or include non-integers, so like you'd have to go by halves or maybe even a quarters or whatnot, but to get a more accurate graph. We want to try to sketch the graph of this, so I just randomly picked these x values here, and I'm just going to take those x values, plug it into the function, figure out output values, and then go from there. So, if you can't do this mentally, obviously you'll try to want to use a calculator, but it's fairly important here. So, -4, this is going to keep going smaller, so I'm not going to really worry about that one. I know that this value here is going to keep going smaller and smaller and smaller, so, or keep going negative, further negative. So the 3, I'm not going to really worry about that right now. Just have my work all done. If I would have had more room, I would have kept my work, but I'm going to erase it and get it out of the way. And then go ahead and plot my points. So I'll plot my points. I have -4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I have 1 point here. -3, -4. 1, 2, 3, 1, 2, 3, 4. And then I have -2, -3. -1, 2. And I have 0, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I have 1, 0. And I have 2, -19. This clear down here. Okay? So there's our graph. Now, if we have a gist of where or how this graph should lay out, which we should, because we know the behaviors of our graph. Remember our negative, our x cubed, it's like our disco situation, okay? And then the negative flips it, okay? So then, often in my mind, I know that my graph should look something like this. Okay, here, let me draw that a little better. Look something like this. All right? So that's kind of how I'm just gonna trace this graph out till it fits that situation. So, and this is a situation where you just try to do the best you can. So here I go. I go down. So there we go. There would be the graph of, the sketch of the graph of -x cubed minus 4x squared plus 5. All right. Fairly simple deal. One thing that we should need to get better at, and that we'll do in the next example, and that is more determine where these zeros are at. We obviously found this one exactly. This is exact here, 0. But these two right here are not so exact. So therefore, we want to, really isolate or find those exact zeros. That would make our graph a lot more accurate. So there's example 1. We're going to do example 2 here in a second. All right, so just the second example here. Gonna kind of get the zeros just a little bit more, locate them a little bit more accurately, and kind of explain that just a little further. So I have an example here. F of x, x to the 4th minus x cubed minus 4x squared plus 1. Again, a table of values. I'm just going to kind of go ahead and plug these in mentally and try to figure this out as quickly as I can. So if I plug -2 in, get 9. I plug negative 1 into this function up here. I'm going to get negative 1. If I plug 0 in, that should be easy. Just get 1. I plug 1 in, I get 1 minus 1 minus 1 plus 1 is negative 3. Actually, that's minus 4. So I got negative 3 there. I plug 2 in, I'm going to get 15, 8, negative 7. 3 I plug in, I end up getting 19. So there's some values that I am getting, and plug those in and get those mentally. But if you can't do that mentally, make sure you show your work and get the correct value. So I'm going to analyze my table before I get too carried away here, and I want to just kind of show you something. And that is, notice here that I have on the left side, I have consecutive integers in my domain from left to right on my x-axis. Okay, so if I have this graphed, as accurate as I can, just freehanding it. But so here's negative 2, here's negative 1. Now in between there, it's saying that my function changes values. Okay, there's a sign change in here. Okay, a sign change. What that means is it goes from positive to being negative. So that means at negative 2, my function f of x was positive. So at f of negative 2, my function's positive. It's up here. But then when I go to negative 1, my function's negative. There's a sign change. Okay, so that means my graph has to cross somewhere between negative 2 and negative 1. All right? The same thing goes from negative 1 to 1. There's a sign change here as well. Okay? So that means your graph has to cross somewhere between negative 1 and 0. All right? And then another sign change. 1 and negative 3. So there's a way of showing, by analyzing your graph, there's a way of showing that there's sign changes. With the sign changes, this is actually called the location principle. Okay, the location principle of finding those zeros and where they would be. All right. So let's go ahead and plot these points. Negative 2. Put these points in here. This one might not be as pretty as the last one. Try. Negative 2, 9. It goes positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, right there, negative 1, 1. Negative 1, negative 1. So, right there, notice, if I cross in between negative 2 and negative 1 somewhere, 0, 1. 1, negative 3. 3. 2, negative 7. And then 3, 19 is clear down. So, x to the 4th. Oh, I'm sorry, it's positive. Negative 7. 3 is positive 19. So that's way up here. All right. Okay, so here we go. So I have a situation where my graph, and again, 4th degree polynomial. Remember, it's a U-shaped graph. It's positive, so it should kind of look like a W, right? So here we go. If we start, let's just use green here. So if I come down here, I'm gonna come down. It has to be between negative 2 and negative 1. Has to be between there. Okay. And then I come down, I'm going to come through, not necessarily, I'm not sure where I would start. I guess I haven't really covered that yet. We'll come down here. It's got to make a turn in here somewhere and come back up between 0 and -1, and then make another go through here, and then between between -1 and 0, between 0 and 1, it's got to go up through here and then make a turn here somewhere and come back down through, touch this point, and then come up back through 2 and between 2 and 3. So I need to make that a little sharper. Okay, there we go. Now these are more exact because I know they got to go between -2 and -1, -1 and 0, 0 and 1, and then 2 and 3. Okay, just by analyzing my graph right here, my table of values. All right, a little bit more accurate. Now I'm not really sure. One thing I'm not really accurate with is these turns right here. But I do know that you have to, once you go through the point, sometimes that point might be where you touch it and then go right back up, which, sometimes it's highly unlikely that, that's the case. But, there are times that happens. And we'll kind of discuss that here, as we go along. But these two examples are examples of trying to get the values or the graphs graphed and do it by hand. Now, most likely we have computer programs that are going to do this for us. So I do want to practice doing it by hand. I do want you to think, and what's that graph going to look like? That's what you should be able to do mentally, okay? Because there's always a possibility that you're going to plug something into a computer, and without thinking, you might have the wrong graph. If you don't think about it a little bit, and that's what I want you to do. That's what I want you to be able to do. All right, here in a second, I'm going to give you some try this problems. All right, here's 2 try this problems. Sketch the graph of this one, sketch the graph of this one, and determine the consecutive values. Basically what we did on the last problem. So that's what these instructions here mean. Determine the consecutive values of x between each real 0 is located. So analyze your table of values for that problem there, for number 2. All right, there you go.